Welcome back to the channel. Today we are going to discuss the new chapter motion. In everyday life, we see some object at rest and others in motion. Birds fly, fish swim, blood flows through veins and arteries, and cars move. Atoms, molecules, planets, stars, and galaxies are all in motion. We often perceive an object to be in motion when its position changes with time, not the point. We often perceive an object to be in motion when its position changes with time. However, there are situations where the motion is inferred through indirect evidences. For example, we infer the motion of air by observing the movement of dust and the movement of leaves and branches of trees. What causes the phenomena of sunrise and sunset and changing of seasons? Is it due to the motion of the earth? If it is true, why don't we directly perceive the motion of the earth? An object may appear to be moving for one person and stationary for some other. For the passengers in a moving bus, the roadside trees appear to be moving backwards. A person standing on the roadside perceives the bus along with the passengers as moving. However, a passenger inside the bus sees his fellow passengers to be at rest. What do these observations indicate? Most of the motions are complex. Some objects may move in a straight line and others may take in a circular path. Some may rotate and a few others may vibrate. There may be situations involving a combination of these. In this chapter, we shall first learn to describe the motion of objects along a straight line. Then we shall also learn to express such motions through simple equations and graphs. Later we shall discuss the ways of describing circular motion. So we go through the topics. What is motion? The movement of a body or object is called motion. So what is rest? Listen, an object is said to be at rest if it does not change its position with the time. I repeat, an object is said to be at rest if it does not change its position with the time. So what is motion? An object is said to be in motion if it changes its position with the time. A bird flying in air, a train moving on rails, a ship sailing on water, a man walking on road are some examples of motion. Okay. So listen to the definition. A body is said to be in motion when its position, underline, when its position changes continuously with respect to a stationary object taken as reference point. So what is reference point? It is a point used to find or describe the location of something. For example, when you look out the window of a car and notice that you are moving faster than the car next to you. The car next to you is moving. It is just moving slower than your car. You use that other car as a reference point to determine that your car is moving. I hope it is clear. So reference point is a point which is used for describe or find the location of something. Okay, clear? So the next topic is what is distance. Distance means it's the actual length of the path covered by a moving body, irrespective of the direction in which the body travels. Which means if a body travels, it is a actual length. It is the actual length of the path. That is underline the word the actual length. Okay, the actual length of the path covered by a moving body. That is called distance. Okay. So what is displacement? Displacement, it is the straight line path between initial and final positions. Or the second definition, the shortest distance between initial and final position. The shortest distance between initial and final position. So listen to the diagram. So this diagram explains what is distance and what is displacement. So we say that what is distance? It is a actual path covered by a body. Listen diagram. A body starts from A and travels to D through the path A, B, C, D. Listen. A body travels from A to D through the path A, B, C, D, which means A to B and B to C and C to D, which means the total distance covered is between A and D R is equal to that is A to B distance, that is 4 km, and B to C distance 3 km, and C to D distance 6 km. Total 4 plus 3 plus 6, that is equal to 13 km. I hope you understood. Okay, the distance which means the actual path covered by that body. Okay, so what is displacement? It is the shortest distance, which means in this diagram the shortest distance is AD. Between the shortest between the points A and D are AD, that is 2.5 km. The shortest distance. Okay, then listen to the point. The distance is a scalar quantity and displacement is a vector quantity, which means distance is a scalar, means distance has only magnitude, and displacement is a vector quantity, which means displacement has both magnitude and direction. Displacement has magnitude and direction. Okay, look at the first problem. It explains what is distance and what is displacement. Okay, the first problem, it's a simple problem. Calculate the distance and displacement if the person travels from A to A. So listen to the diagram. A person travels from A to A. Listen to the point A. This is the point A. This is the point A. A body travels from A to A. Okay, this path. A body travels through this path from A to A. Say complete a circular path. Okay, so what is distance? We know that what is distance? It is the actual path covered by a body, which means this body, this person starts the journey from here, then travels through the circular path and reaches A, which means the person travels through the circumference of the circle. Which means what is distance? Circumference of the circle, that is total length of the path, is equal to circumference of the circular track, which is equal to, we know that circumference of a circle is equal to 2 pi r, where r is the radius of the earth. Is it clear? I repeat, this is point A. The body travels from A to A means if the person travels from here travels through the circular path and reaches A, which means the actual path, this is the actual path covered, this is the actual path covered by the body. Okay, that is total distance is equal to total length of the path, which is equal to circumference. Okay, so what is displacement? This displacement is equal to 0. Why it is 0? As the body starts the journey from here, then reaches A, which means the end point and the starting point are same, which means displacement is 0. Displacement is a vector quantity. It consider the displacement has both magnitude and direction. That is why it is 0. I hope it is clear. So we are moving on to the next problem. Okay, a man travels a distance of 1.5 meter towards east, then 2 meter towards south, and finally 4.5 meter towards east. Find distance and okay, listen to the diagram. The body travels from A to B. The body travels from A to B. A man travels at a distance of 1.5 towards east. Doko. Just A to B. The person travels from A to B, that is 1.5 meter east. The direction is east. Okay, then 2 meter towards south. Which means the 2 meter towards south. Then finally 4.5 meter towards east. Then look at the diagram, that is C to D is the distance. Okay. So first question is the actual distance. Actual distance means the total path. Distance means the total path covered by that man. Which means that is AB plus BC plus CD. That is equal to 1.5 plus 2 plus 4.5 is equal to 8 meter. Okay. I hope it is clear. Then what is displacement? Displacement means it is the shortest distance between A and T. Look at the diagram. The shortest distance between A and D is this path. This dotted line shows the shortest distance between the 2 points. Okay. So this is the displacement. So measure using a scale. So we get 6.3 meter. Okay. These problems will clearly explain the concept of distance and displacement. Okay. Okay, move on to the next topic, uniform motion. Listen, a body has in uniform motion if it travels equal distances in equal intervals of time. A body has in uniform motion if it travels equal distances in equal intervals of time. Okay, listen to this diagram. Okay, a body starts its journey from here, its journey at 4 a.m. and covers a distance of 2 kilometer by 5 a.m. Okay, I repeat, a body okay, a body starts its journey at 4 a.m. Covers a distance of 2 kilometer by 5 a.m. Okay. Then after 1 hour it clears 2 kilometer. After 1 hour it clears 2 meter, which means 2 kilometer. Okay, which means the body covers equal distances in equal intervals of time. I repeat, a body has a uniform motion if it covers equal distances in equal intervals of time. Okay, so what is non-uniform motion? As if it travels unequal distances, underline unequal distances in equal intervals of time. Okay, non-uniform motion is also called accelerated motion. Okay, so the next topic is speed. What is speed? It is a distance traveled by a body per unit time. It is a distance traveled by a body per unit time. That is, speed is equal to distance by time taken. Speed is equal to distance by time taken. SI unit of speed is meter per second. Note that speed is a scalar quantity, which means it has only magnitude. So speed has only magnitude. That's it. That's why it is a scalar quantity. Okay. These are simple topics, simple concepts. Okay. So look at the graph. Okay, it is a uniform motion. So we clear that time on x-axis and distance on y-axis. It is clear that it is a linear graph, which means it covers equal distances in equal intervals of time. Okay, it clears equal distances in equal intervals of time. So it is a uniform motion. Okay, so the next graph, this is a graph of non-uniform motion. It is clear that it covers unequal distances in unequal intervals of time. Okay, the diagram, it is not linear. Okay, so it covers unequal distances in unequal intervals of time. I hope it is clear. Okay, so what is average speed? We heard about average. So here average speed is the distance covered by time. So what is average speed? It is the total distance traveled by a body divided by total time taken. That's all. Speed is the distance by time. So what is average speed? S, the total distance covered by the body divided by total time taken. That's all. Okay. The question number 3 will explain the concept of average speed. Okay. Listen to that question. An object travels 16 meter in 4 seconds and then another 16 meter in 2 seconds. What is the average speed of the object? What is the average speed of the object? Okay, so listen to the diagram. A body travels 16 meter. This is 16 meter in 4 seconds and 16 meter in 2 seconds. Okay, so the total distance is equal to 16 plus 16, which is the total path length, total path covered by the object. That is 16 plus 16 is equal to 32 meter. The total time is equal to 4 seconds plus 2 seconds, that is equal to 6 seconds. Very simple problem. It will clearly explain what is average speed. Average. Okay. That is average speed is equal to total distance by total time. That is total distance is equal to 32 meter by 6. That is equal to 5.33 meter per second. Okay. I hope it is clear. So move on to the next problem. It's a very good problem. A train A traveled a distance of 120 km in 3 hours, whereas another train B traveled a distance of 180 km in 4 hours. Which train traveled faster? So simple example. So there are two cases. So train A and train B. Here, first train number A traveled a distance of 120 km in 3 hours. So we are considering the first case. For train A, listen to that one. For train A, we know that speed is equal to distance by time. So distance covered by the first train, that is A, train A, is 120 km. That is, say, Distance is equal to 120 kilometer divided by time is 3 hours, that is 120 by 3, that is equal to 40 kilometer per hour. It's a very simple problem. Is it okay? So we get the value of speed of first train A. Okay. Then for train B, we know that for train B traveled a distance of 190 kilometer in 4 hours. So SB, what is SB? The speed of train B. SB is the speed of train B. SA is the speed of train A. That is SB is the speed of train B, that is equal to distance. The distance is 190 kilometer divided by, that is time, that is equal to 4 hours. That is equal to 45 kilometer per hour. So we get for train A travels at a speed of 40 km per hour. For train B travels at a speed of 45 km per hour. So the train B travel faster. That is the answer. I hope it is clear. So we are move on to the next problem. A car travels 30 km at a uniform speed of 40 km per hour and next 30 km at a uniform speed of 20 km per hour. Find its average speed. It's a good problem. So we listen to this point. Okay, we know that speed is equal to distance by time. Then time is equal to distance by speed. Note that formula. Time is equal to distance by speed. Okay, so look at this diagram. So a car travels 30 kilometer. This is a 30 kilometer at a speed of 40 kilometer per hour. Then next 30 kilometer at a speed of 20 kilometer per hour. Okay, so we have to find the average speed. We know that average speed is equal to total distance by total time. We get the total distance is 30 kilometer plus 30 kilometer, that is equal to 60 kilometer. So we have to find the time of two cases. So here T1, look at this step. T1 is the time taken to travel the first 30 kilometer at a speed of 40 kilometer per hour. Time T1 is equal to, it is the time taken to travel 30 kilometer distance at a speed of 40 kilometer per hour. Look at T1 is equal to, we know that time is equal to distance by speed. That is T1 is equal to time distance is equal to 30 kilometer by speed 40. That is equal to 3 by 4. That is a 3 by 4 is the time taken to clear first 30 kilometer at a speed of 40 kilometer per hour. Okay, so what is time T2? T2 is the time taken to cover next 30 kilometer at a speed of 20 kilometer per hour. Okay, look at this. There T2 is equal to 30 by 20. 30 is the distance and 20 is the speed of next 30 kilometer. That is equal to 3 by 2. Okay, so the average speed is equal to total distance by total time, which is equal to total distance 30 plus 30, that is equal to 60. That is total time is equal to 3 by 4 plus 3 by 2. That is T1 plus T2. T1 is the time taken to complete first 30 kilometer. T2 is the time taken to complete next 30 kilometer. Okay, that is, we get the answer 26.6 kilometer per hour. So these three problems will clearly explains the concept of average speed and speed. I hope it is clear. I repeat, speed is the distance traveled per unit time. Average speed. So average means average. That is, average speed is the total distance by total time. I hope it is clear. So we are move on to the next topic, velocity. Okay. So we studied earlier what is distance. Distance is the total path covered by the body. So what is displacement? It is the shortest distance. It is the shortest distance between 2 points. Okay, the velocity is the distance traveled by a body per unit time in a given direction. Underline the word, in a given direction. We know that speed, and what is speed? Speed is the distance traveled per unit time. But the velocity is the distance traveled per unit time in a given direction. Which means here the distance is the displacement. Okay, here the velocity is equal to displacement by time. That is here, not the sentence. Okay, that is distance traveled by a body per unit time. Okay, in a given direction, which means that distance is considered as displacement. It has magnitude and direction. Okay, so unit of velocity is meter per second, same as speed. Okay, and this is a vector quantity. So speed is a scalar quantity. It has only magnitude, and velocity is a vector quantity. I hope it is clear. Okay, the next one is uniform velocity. Uniform means same. Okay, so what is uniform velocity? A body has a uniform velocity if it travels in a specified direction in a straight line, moves over equal distances in equal intervals of time. Equal distances in equal intervals of time. That is called the uniform velocity. Okay, listen to that point. Uniform velocity. Velocity means what is velocity? It is equal distances in equal intervals of distance covered in unit time in a given direction. That is velocity. What is speed? Distance covered in a unit time. That is only speed. If it has considered direction, so it is so the quantity changes to velocity. Okay. So look at the table. Speed has only magnitude. We know that, and velocity has magnitude and direction. And speed is a scalar quantity, and velocity is a vector quantity.